Last week on the show, we had our windows installed, our beautiful PVC siding went on, and to complete the exterior, we had our gutters and downspouts installed.
You're watching Built-In NL on NTV.
As the construction of new homes continually produce a tighter building envelope with less drafts and heat loss, heating a home has become an awful lot more efficient. The only downside to this is that there's not much natural air circulation. This can cause stale air and condensation to gather in the home. So to combat this, we'll need to install a HRV or heat recovering ventilation system. So we called Adam to help us out.
My name is Adam Rickert. I'm the owner-operator of a company called Hot Water and Fresh Air Systems. We're a heating and ventilation contractor, and we specialize in hot water and steam heating systems, heat recovery ventilation, and zoning and controls. That's the system that will take the stale air out of kitchens and bathrooms, recover the heat from that air, and then push it out of the house. We use an insulated flexible duct because we had to go through the attic. And for a long run of insulated flexible, I decided to upsize to 8-inch to reduce friction on the airflow.
Now that we have the HRV rough-in place, it's time for Steve and Jimmy to come back and install the rest of our plumbing. Today they're going to install the rest of our potable water lines as well as the plumbing vents through our roof. Here Steve puts together our water lines that will eventually bring hot and cold water to our main bath shower. Here Jimmy installs some of our ABS pipes that will carry wastewater into our drainage and septic system, as well as the vent through our roof. While all that's going on, Blair and his team are beginning our electrical install. They will spend a couple days running wire throughout the entire house and complete the rough-in. It's critical at this point that everyone works together to complete their work on time.
My name is Blair Keats, and I'm the owner of Legacy Electric.
So Blair, our electrician, is back today and giving us a hand with our electrical hookup.
I think so.
Dealing with Blair is awesome. I don't need to deal with a thing. The power companies, the materials, none of that. Blair takes care of everything. Now don't tell Blair, but I'm pretty sure I'd be lost without him.
It's important to have a good plan in place long before the work starts. I like to meet the client, designers, cabinet makers, and any other people that require electrical connections pre-job to ensure no surprises. After the pre-job planning is complete, we start by marking all the switches and plug locations. This will help us determine how many circuits we will require. It's not as easy as you would think just to add a light here or install another plug there after the rough-in is complete. There are calculated loads on every circuit we install, and adding another light or receptacle could overload the circuit. We've decided to go with a 400 amp service for this project. Some people run into issues after the home is built by not having enough space in the panel or power to accommodate things like a detached garage or a hot tub. So this will ensure Mike and his family will have all the power they need for years to come. It was a modest upgrade, but could save many thousands in the future. We put 6mm poly behind all the boxes on the exterior walls and the boxes in the attic so the insulators can get a good seal. We like to leave a loop of extra wire outside the boxes just in case something happens to the ends inside the box during construction. One nice upgrade we put in this home for Mike is a floor plug. This allows the placement of a plug in the middle of an open concept room. This is normally pretty simple, but in a slab-on grade like this, it requires planning months ahead of time.
Just pulling the wire across for the floor plug in the living room. We're at the other end of this wire here to fish it. You're going to pull this across through the conduit in the floor, and this end of this is going to get put into the panel. You go ahead and pull.
Alright, so basically what we're going to do, we're going to skin the wires, we're going to put them in the box, we're going to make our splices, and we're going to have it all ready for switches. So as soon as drywall goes on, we can pull our wires out, put our switches on, and it's a done deal. I'm going to mark the wires to where they're going, so it makes it easier for me to make my splices. So the box is now ready for switches. We just gotta wait for the drywall to go on first. This is a 4-inch insulated pot-like housing. We'll be installing it throughout Mike's house.
So because we're not on city water and sewer services here in our location, there's two things that are going to need to happen. First, we're going to drill an artesian water well, and that'll take care of all of our water needs. The second thing we're going to need to do is install a septic system, and that'll take care of the waste. So if you can remember a little earlier this season, my friend Jeff came along and helped us with the footings and foundation for our project. And not only is Jeff a great carpenter, but he designed the septic for this system as well.
So this morning we're going to install our septic system. We're going to start off by installing the septic tank.
It's nice to deal with tradesmen that understand the bigger picture of your construction project. And because Jeff is like a Swiss Army knife of the construction industry, it made my job as a general contractor much easier. This large holding tank will be the first stop for our wastewater coming out of our home. Most of the heavy solid waste sinks to the bottom and stays in this tank, while the rest of the waste overflows into the distribution box and out into the yard in the absorption trenches, also known as our septic field. The distribution box is a very important component of our septic system. Without even distribution of effluent, the septic field will be used unevenly, causing portions of the system to become overloaded and potentially fail. Pull this out and shove it in the other side there.
After we set the distribution box, we're going to install 3 70-foot absorption trenches and backfill with 1.5 inch stone and await service NL inspection.
Now that our absorption lines are completed, I can leave Jeff to fill these in and level out what will eventually become our front yard. The very last thing that needs to be installed to service our house is a water well. And this part is critical. A poorly installed artesian well can be a real problem. Bad water is one thing we don't want to deal with, so we called around and seemed to come up with the same reference from a bunch of people. And this is the first time I've ever had to service a home with a well, so the fine folks at Squire's Water Well Drilling were more than happy to walk me through this process.
Hi, I'm Rod Squires. I own Squires Water Well Drilling along with my wife, Darlene. At Squires Water Well Drilling, we drill artesian water wells and geothermal heat pump holes for our commercial and residential customers. We also troubleshoot older artesian wells and provide solutions to correct any problems. When we arrive on site and meet with our customer, if it's a new home, we usually follow the details laid out in the plot plan for the septic design. Septic design also has the well location on it. If we got to make any deviations from it, we take into consideration all sources of contamination and hazards such as electrical wires here in the background. When the equipment moves in on site, we set it up and secure the site so that there are no hazards. And we begin drilling the hole. We start off with a larger diameter hole, a 9-inch hole. We drill down into the bedrock and penetrate into it about 20 feet on average, using a minimum of 42 feet of casing on all our wells. This ensures that there's no surface water contaminants able to enter into the well. We also provide a bentonite grout that helps seal the annulus of the casing. Then we go down through the casing with a 6-inch bit and start drilling for artesian water. So basically what we're doing is we're drilling down through the rock. As we're drilling, we're injecting a small drop of water. It keeps the hole washed and prevents dust and everything from clogging up the seams and fractures in the rock. Water can't pass through solid rock, so therefore the only place we can encounter water in rock is run through seams and fissures in the rock. And the objective is to go down and keep these as clear as possible, so that when you get enough of them, or if you strike into one big fracture, it could be a cumulative effect of a bunch of seams providing a half a gallon a minute each, or possibly even less, or just one joint seam that could give you 20 to hundreds of gallons a minute. When we drill our wells, we design them to the customer's needs, but we do have a minimum that we require, and we go by CMHC standards. So when we reach that minimum, we inform the customer what's there, and then the customer has the choice of, if he wants to, he can say, for instance, if he's got to maintain, or he has plans of maintaining a swimming pool, or he's got large hot tubs, spas or whatever, he can opt to drill deeper to create more storage, or in the event of drilling, we could also encounter larger flows of water. Once drilling is completed, we remove our equipment, the well is shock chlorinated, capped off, and then we wait for the customer to notify us when he's ready for the pump installation.
We're at Mike's house. We're going to be installing the ground service for his pump system, which includes the tech cable, the pitless adapter, and also the water line into his home. And then, of course, we're going to come back and put his pump down as well and hook up his water so he has water for his home.
Should have caught me on the first one, but it went so much easier.
Basically what we're doing is we're digging down between 3.5 to 4 feet to get below the cross line. This will ensure that the lines don't freeze during the winter, because of course with a steel pipe it'll actually travel down faster. So we're just leveling off now, getting ready to put the hole in the casing so we can put the pitless adapter in. What they're doing now is they're joining the tech cable onto the well cap, which is going to be the power feed to the control box inside. We're here to install a pump system for Mike's well today. We're using the Stay Right 2000. It's a Pentair pump. It's 1 horsepower, 7 gallon a minute pump that we're actually the dealer for. And that's basically it. Phil's getting ready to put the 1 1/4 inch male adapter into the top of the pump. This here is a torque arrestor. This actually will go on the pump on the hose. Will actually keep the pump in the center of the well, so it don't be kicking and causing any type of chafing. Tries the last one off, so 2 gallons, great. Just a handle.
That's it for this episode, folks. Come back and join us again next week as we continue to build our home right here on Built in NL.